Page 6 of our notes, a Venn diagram. We usually capitalize the word Venn. It refers to someone's name, so it's named after some person that discovered or invented it. A Venn diagram represents all possible relations between I don't remember what that word is supposed to be. A collection of different sets or objects. A collection of data of different sets or objects. The overlapping area contains elements of both sets called the intersection. Okay, so last time was a little activity. I had everyone go through and check off which diagram would go with which situation. So this has two circles, which means it has two different subsets of data. However, they're not overlapping, so that means that there's no way for those two sets to be the same thing, right? So we decided that that was fruits and vegetables, because something is either going to be considered a fruit or considered a vegetable, and probably not both, unless you want to, for some reason, put a tomato in both, because by biological definition, a tomato is a fruit, because it's the flesh around, like the seeds, right? But a lot of times we consider a tomato a vegetable because it's less sweet and more savory. However, regardless of how you define fruits and vegetables, in general, you would not have any fruits in the vegetable group and no vegetables in the fruit group, and so therefore they don't overlap. Group students in my class based on height, hair color, and eye color. That's three things to compare them with. So I would need three different circles to organize that data and show how they overlap. Compare the numbers that are multiples of 7 to the numbers that are multiples of 2. So that one would be this one, because if you go 2 times 7, you get 14. And 14 could go in the middle, because 14 is both a multiple of 7 and a multiple of 2. There's other numbers like that as well, like 28 would be one of those, and 56, and any numbers that are divisible by both 7 and 2. Okay, compare stores that use red in their signs to stores that use blue in their signs. So we figured that could also be both, because you have some stores that just have one color or the other. So like Walmart, I think, is just blue, right? Kmart, I think, used to just be red. Target, that's a better example, because Kmart we don't have anymore, really. So Target is just red, but then we have places like Domino's that has both red and blue in the sign, right? So there's an overlap of that situation. So then, suppose you were asked to place the numbers 7, 11, 77, 121, 88, 5, 50, 55, 110 in a Venn diagram. What categories would you use, and how many circles would you use? There's probably different ways to do this. The one that comes to my mind, first of all, is I noticed that there's some numbers divisible by 7. And then I noticed that there's numbers divisible by 11. And then I noticed that there's numbers that are divisible by 5. So everything can fit into one of those categories: divides by 7, divides by 11, or divides by 5. So I could do 3 different categories, right? And so that means there would be 3 circles. And I could divide them into categories of multiples of 7, multiples of 11, and multiples of 5. Now there's probably other ways you could do this, and just for fun I would encourage you to actually try creating those. I think I did that in this particular class. We created those together. That could be a good little practice activity to see if you could make a Venn diagram with those 3 categories with the 3 overlapping circles. I don't think we would have numbers in all of the spaces in our overlapping circles, because if you have 3 overlapping circles, you actually have 1, 2, 3, 4, 5, 6, 7 spaces that you can put things in, and some of them could be empty, and that's okay. All right, moving on. on to page 8. Page 8 I kind of already looked at in another video where we looked at what each of the Venn diagram and set situations would look like, right? So if we have an A union B, where we have two overlapping sets A and B, that would include everything in set A and everything in set B and everything where they overlap. If I have a set A intersection B, that would be just where the two sets intersect, so just the overlap. If I had something like A complement, what's not in A, notice how everything in set A I have left empty, and I've colored everything else in set B and around that. And then for the relative complement, that's just the part in set A that's not in the overlap with set B. All right, quickly we're going to look at another example. Consider a universal set containing the whole numbers from 0 to 9. So for some reason it says natural numbers, but technically those would be the whole numbers, when natural numbers are like 1, 2, 3, 4. So the difference between natural numbers and whole numbers is that whole numbers start at 0. So 0 to 9. Okay, so let's look at our sets. We have a set A and a set B. So we'll call this set A, call this set B. So set A has a 4, a 7, and a 9. Now before I write that down, I'm going to look at set B. Set B has a 1, 2, 3, 4, 5. So I just noticed at a glance that both set A and set B have a 4 in them, but that's the only thing they both have. So that 4 will go in the middle because it's in both sets. Now set A will have a 7 and a 9. Set B will have a 1, a 2, a 3, we already have the 4, and then a 5. Okay, now remember we're referring to the universal set from 0 to 9. That means we need to have all of the numbers from 0 to 9 somewhere. So there's no 0 in either of these sets, so we need to put a 0 somewhere out here. We have a 1, we have a 2, we have a 3, we have a 4, we have a 5, but we don't have a 6. So we need to put a 6 somewhere outside of these circles. And then we have a 7, but we don't have an 8, so let's throw an 8 outside somewhere. And a 9. So when you're putting numbers that are in your universal set in your picture, they go outside of the circles, but it doesn't matter where they go outside of the circles. I'm trying to stay in the rectangle, like that's my universal set, but they don't have to. They just have to be outside of the circles, right? My rectangle that I created is a little small, so if you don't really have room for it, that's okay. Okay, number 1, fill in the Venn diagram, include all the numbers from 0 to 9, label each circle with the name A or B of the set. So I did that. Now we're going to list sets with the following characteristics. So we want the union of set A and B. So the union of sets A and B would include all of the numbers in set B and all of the numbers in set A. And it includes that number that they both share, right? But we just write it once. The intersection of sets A and B is just what they have in common in the middle. So just the 4 that's in the middle, that's the union. I mean the intersection. Wrong word. Complement of A. The complement of A is everything that is not in A. So you could write that down if you want to help you remember what that means. So not in A. So in A we have a 7 and a 9 and a 4. So not in A, we have a 1, a 2, a 3, a 5, a 6, a 0, and an 8. Those are the numbers that are not in set A. No 7, no 4, no 9, right? For the complement of B, we're finding numbers that are not in set B. So in set B, we have 1, 2, 3, 4, and 5. So anything not in set B would be 0, and then 6, 7, 8, and 9. So notice how we're including the extra numbers that are in set A, the 7 and the 9, along with the numbers that were not in either set, the 0, the 6, and the 8. Now, I wouldn't mind if we actually did the relative complements as well, so I'm going to add those on. So let's do a relative complement of A to B. The relative complement of A to B would just be 7 and 9. correct? Because it's just the numbers that are in A that are not in B. Let's switch that a little bit and do the relative complement of B to A. So that would be just the numbers that are in B. Let me extend this so we can see the whole page a little better. Just the numbers that are in B, but not the number that's in A. So we would include the 1, 2, 3, and 5, but not the 4. 1, 2, 3, 5. So there's, again, another example of that relative complement that you're going to see on the Khan Academy assignment.